All right, so again, welcome to class today. We're going to pick up where we left off. Last class period, we talked about the life cycle, right? The programming life cycle phases. And what were those phases? Put them in the chat for me, please. Let's see if you recall. What are the programming life cycle phases that we discussed in great detail last class period? Okay, problem solving phase, implementation, maintenance phase. Okay, absolutely. Exactly. And so you should appreciate what takes place. Very good. Thank you for that. Excellent. I love the class participation. Let's promise to keep this same level of class participation, whether you put it in chat, unmute yourself, raise your hand. If you have questions or concerns, do not hesitate. Okay, this is our time together. Let me know. Okay, let me know if there are questions or concerns. I'd be glad to assist. But yes, you're so correct. These are all the life cycle phases. Problem solving is our initial phase where given a problem, we analyze the problem, we design a solution, a general solution, create an algorithm, a general solution to solve the problem, and then we test it. We test it to ensure, right, that we're truly solving the problem, right? The implementation phase, we build that based off of the design that we've come up with, that we've come up with, and we build using a tool like Java. And what do we do once we've taken that general solution and turned it into, translated it into code using a specific programming language like Java? We then test that to ensure that given the inputs, do we get the expected outputs? That's how we know that our program really works, right? And then we, of course, talked about the maintenance phase, is when that software, that application is in use by users. Okay, and modifications can still be made even after the program is being used by users. All right, so with that being said, you were asked last class period to identify a programming environment. And so what I'm going to do today, before we leave today, we are going to write our first program. And so let's just get started, because today on, we're coding most class periods. Pretty much every class period, we're going to be writing some code, okay? And so you were asked to identify your programming environment of choice, and I'll demonstrate mine. But again, whatever programming environment you choose, what we do today, we're going to organize ourselves. You may have to, if you're not using the same environment that I'm using, you may hopefully I'll give you some recommendations and tips on how to organize your environment. It may not be exactly the same, but these are things you need to take into consideration as we proceed with the course. All right, so with that being said, you can go to your modules page on your course website. Make sure you have your programming environment of choice open, as well as your textbook and your course website. Now, let's just make this very clear. These are the three, at minimum, these are the three things that need to be open at the beginning of class, every single class period. Okay, course website, all right, textbook, and programming environment. Those are the three. So I'm not going to, you may hear me say it again. I can't help myself. But these are the things that I want to make sure that are open at the very beginning of class. All right, so if you're on your modules page, if you scroll down to lesson 2, you should see the link that says lecture notes and in-class activities. You can go ahead and click that. Now you can follow along with the notes or just look at the notes that I have, but I do want to bring it to your attention that it is my goal to always have the lecture notes available to you ahead of time. They're all there. Maybe 1 or 2 slides may be slightly off, but I do try to keep it updated. All right, so with that being said, we're gonna pick up where we left off. The last thing that we talked about was, again, the programming life cycle. I want to introduce you to what a Java program looks like. Of course, now I said at the beginning of the semester, I asked, who knows, what languages do you know? There were several that mentioned, I know this language, that language. My expectation, or the way I approach this class, and remember, there is no prerequisite for this course. So my assumption is that, hey, you may not know a language. You may, so this is, I know that majority of you, at least half of you, this is your first language. So no worries, okay? So this is what a simple Java program looks like. So we're going to be talking about some do's and don'ts for sure. So make sure you have a way to take notes. And I will show you once I get into my programming environment, I'll show you what I usually do to take notes, even during class. But until then, just make sure you have some way to take notes for sure. So this is what a Java program looks like, a simple Java program. You see the file name of this program is welcome.java. So the extension, FYI, for all Java programs, might want to write this down, all programs that are Java programs that need to be compiled, need to be executed, those files need to end in .java, and that's all lowercase. Okay, so all Java compilers look for files with that extension, and those are the files that they will compile and execute. They must end in .java. What other things will your compiler look for? Well, the compiler also looks for the following. The name that you give your file must be the same name for the class. So whatever class, the name of the class that you define, and this is user defined, you'll see that there are two keywords right in front, and we call these reserved words. Remember, I talked about when I talked about what is a programming language, I told you that it's strict grammatical rules and reserved words or special words. Well, public and class are considered to be on that list of special words and reserved words. So our programs, our Java classes always start with, our Java programs always start with the word public and the word class, those special words, okay? And we'll talk about what public and class mean, definitely, but not necessarily today. So public and class, that announces to our Java compiler, hey, this is a Java program. And here we see the word, the name of the class. And we'll talk about what a class is for sure, but the name of this class, this Java program, is called Welcome. That's the name of this Java program. Why? How do I know that? Because it always follows the name of the program, of the Java program, always follows the keyword class. Here's some recommendations that Java, the language, right? Both the developers of the Java language, the recommendations. And by the way, put it in chat. Let me see if you know this. Who are the developers and who are the developers of Java? Those the company that, or an organization that is responsible for maintaining and maintaining the Java language and creating its rules and defining its grammatical rules and updating its classes and who do you think? Anybody have a clue? It is Oracle. It is actually Oracle. Yes, it is the company Oracle. Oracle is responsible, and you're gonna know that for sure. So no worries. But I promise you this. Now the consortium is mainly HTML, CSS, and JavaScript. Is the W3 consortium, right? W3 consortium does that. But yes, you're so correct that Oracle is, and we will do the following. We're going to be, I promise, over the semester, we're going to be looking at documentation, because my goal is this, not to teach you Java. Mainly my goal is to teach you how to solve problems, and we're going to be using the tool Java. So I will definitely show you how to learn a language, right? But I want to show you that, yes, we may be learning the Java language, but the concepts that I want to show you mainly are how to teach yourself any language, right? So we're going to learn Java, but these are also the tasks and the activities that you would use to learn any language. Okay, so after learning, hopefully, this language, you can teach yourself other languages on your own. Yeah. All right, so back to this. The name of this class is called Welcome. The name of the class, here's a very important recommendation by Oracle and those that develop Java, is that we should always name, it's not required, but should always name, give our class name. You should always start your class name with a capital letter, okay, FYI, in Java. The recommendation is that you should always name, right, give your class name, right, start it with a capital letter, which is why you see capital W there. The other requirement, not recommendation, but requirement, is that the name of your class must be the same name as the file name. So you notice that the class name is called Welcome. Well, so is my file name. They have to be the same, everyone. They have to be the same. And it is case sensitive. Okay, and it is case sensitive. So the name of the class must be the same name as the file name, but without the .java extension. So the class name does not end in .java. Okay, but the file name does. Okay, so that is very important. Your program will not compile if this is not the case, if these are not the same. All right, so then we have public static void, right? Public static void, and then main, and then string args. We'll talk about what all of these words mean, but understand this, that all Java classes have this, except what's optional here, of course, what is, of course, the user-defined class name and what you see here. This is just specifically for this program, but what you see, and we're gonna write, so that everything else in this program is pretty much considered to be the shell of a Java program. So public class and whatever the class name is, public static void main, parentheses, stat, string, args, open and close curly brace, closing and closing curly brace, and another closing curly brace. So these are all things that you're going to be familiar with it. So no worries if it's somewhat confusing, but you're going to see. So we're going to walk through how this program is going to, when this program is compiled and executed, and we'll talk about the differences between compiling a program and executing. But when this program is compiled and it compiles successfully and is executed, let's walk through what happens. So when this, we call it tracing, and you're going to hear me say that quite a bit. Let's trace through this program as if we were, right, we were executing this code, right? So let's walk through this code, and what would the computer do if it encountered this code, if it's executing this code? Well, it's going to enter the program, right? And you see those slashes there. We're going to talk about what those slashes are. Those slashes are actually ignored by the computer. What do they call it? Those who are familiar with other languages, what is this called? You're going to read more about it in lesson 2 if you've not already done so. Yes, they're comments, // and specifically, they're what we call one-line comments, right? One line, meaning this. In Java, when we put // in front of a line of code, or in front of a statement, then what does that tell the computer? It tells the computer, ignore this line, because this line is for human consumption, not for the computer. Okay, so we call this comments. These comments are used for humans so that we can document our program properly. We can describe things about our code. And they're very useful for not only the programmer, but programmers tend to work in groups, right? And so, or others come behind them. And so, or even for your sake, you may write the code, and then a month or two or a year later, you want to revisit that code. You want to know, what in the world was I doing there? Well, comments are useful for that. They describe the code, they describe what's going on. And so we have several types of comments, a couple, types of comments that exist, and we'll talk about what those symbols. Remember, we talked about what a programming language is. It consists of strict grammatical rules, reserved words or special words, as well as symbols. And so these // are symbols that we must be mindful of with respect to this language. All right, so when the program is executed by the computer, what is it going to immediately do? It's going to jump inside of the main method. Write this down. This is what we call the main method. Main. And you see what follows that keyword main? Open and close parentheses. Open and close parentheses. So that's the open and close parentheses are what we call, and again, you're going to hear me say these terms over and over again, so no worries if you don't quite get it everything up front. But main is what we call a method, the main method. And how do I know it's a method? Because what follows the word main? Open and close parentheses. That is the indication that we're dealing with a method. Methods do things, okay? Methods will do things for you. So what is the purpose of the main method? The main method in Java is an extremely important method. The main method in Java is what we call, is one of the most important methods. It executes first in any Java program. The main method. So your computer will search for the main method in any Java program. It searches for that main method, and it goes inside of that main method and executes that code first before anything else in the entire Java program. So it drives the execution of a Java program. It always starts there. So I always use the analogy of a relay race, and who always in a relay race, the first leg, right, starts with the first runner always starts with the baton, and the first runner can then pass it off to other runners, but there has to be some runner, there has to be a runner that starts the race, right? Starts the race. And so that is our main method. The main method always has the baton first, and the main method can pass control off to other methods, right? Which we'll learn much later in the semester. But most of the code, and just FYI, this is my approach to teaching this subject, is most of the code that we write in class in lessons 2 through 7, okay, through 2 through 6, rather, 2 through 6, we're going to be shoving all of the code that we write and concepts that we learn in lessons 2 through 6, we're going to be writing that code inside of main, because I want you to learn those concepts. Nothing too heavy about, we're just going to use the main method to learn concepts like what is a loop, what is a branching statement, what are arrays. We're going to just learn how to write those types of statements and when to use them, how to use them, like what is the syntax. We're going to learn how to write them, but we're going to just use the main method initially. And then when we get to lesson 7, we'll learn how to write our own methods outside of main, what we call user-defined methods. And so that won't take place until lesson 7 and 8 after. And so just FYI, that's my approach to teaching a subject like this. Okay, so what is this method? What is this program going to do? Once the computer executes this code, the first line of code that is executed is what you see highlighted right here on the screen. You're going to get so used to this statement, system.out, print L, and that's an LN, not one. LN for print line. That's what that this is also a method. How do we know that print LN is a method? Tell me. I just told you a little bit a few minutes ago. How do I know that print LN is considered to be a method? What gives it away? The open and close parentheses that follow the word print LN. Absolutely. We know that methods do things for us. They will perform actions and tasks for us. And so what is this method called print LN? What is it going to do for us? It's going to print whatever is inside of the open and close parentheses that you see there. And you see that inside of double quotes, what do I have? The string, we call this a string. String is nothing more than one or more characters that are strung together. That's what we call a string. We'll learn a lot more about strings when you get into lesson 2, but definitely when we get into lesson 3. So strings are characters, one or more characters. And I shouldn't even say one or more, sorry, that's wrong. 0 or more characters are considered a string, because there is a special type of string called the empty string, which has no characters. I know. All right, it's just double quotes with nothing in it. All right, but yes, again, everybody, let's pause real quick. Let's take a deep breath. Are we overwhelmed yet? We got this. We got this. We got this. All right. So what's inside here? So you notice that this is what we're going to execute. So system.out.println. This is how we print to the screen. We use system, and that's a capital S, .out.println. So what is system? Let's break this one statement down, and then we'll go further. We'll go into other topics. So system is what we call a predefined Java class, and there are a lot of predefined Java classes. So Java classes are Java code, right? Java code. The developers have made this code available to us, and we can just use it. We didn't even write it, but we can just use it, and it's okay. You don't have to, cite it or anything of that nature. It's predefined Java code that already exists, that we can use it to help us solve problems. That's one of the reasons why Java is so popular. It's because it does have a whole lot of code that's out there and is made available to us. And we're gonna get to learn about some of these Java predefined classes that are out there. We're not going to learn all of them by no means, but we will look at some popular Java and useful Java classes that are out there. And system is one of them. System. So the system class contains several methods and what we call properties. And every Java class contains, and again, I'll reiterate this throughout. Every class contains properties. Well, what are properties? Properties are things that are characteristics about a class. Properties and methods. Methods do things for us. So the system class contains a property. One property that the system class contains is the property out. And you see, it does not end in open and close parentheses. Properties do not. And so I'm just introducing this to you. We will get deeper into what some of these classes offer, properties and methods these classes offer. But out is one property that belongs to the system class. We talked about the importance of naming conventions. I told you that Java recommends that all classes start with a capital letter. That is when we define these class names. So this is a user defined. I could have called it Christy. I could have called it Thursday. Whatever the class name is that we define, the recommendation is that we start it with a capital letter. Well, what about those classes that come along with the Java language that the developers define? They will always start with a capital letter. Java predefined classes always start with a capital letter. FYI, if you say lowercase system, your program will not run. So if we're using a predefined class, you must start it with a capital letter. So this is a predefined class called system. It contains a property called out. What does out stand for, do you think? Put it in the chat. What do you think out will allow us to do in this line of code? It's output, absolutely. So that's why we use the out property, because what are we trying to do in this one line of code? We're trying to print out to the output stream. We're trying to print to the screen. Okay, the opposite of out is in, right? In. Well, the system class also has another property called in. And what do you think the in property that belongs to the system class, what do you think it means? It's input, right? Getting data from our user or data from some source. And one source could be the keyboard. Maybe we ask the user to enter their age from the keyboard. Well, what are we doing? We want that input. We want to grab that input and use it in our program. So you can imagine, going forward, we are going to be using the in property at some point, right? To retrieve data. But if we want to send data out, we have to use this property called out. And now you notice this dot. Well, what is that dot? That dot is very useful. It is also a symbol, all right, an important symbol of this language and other languages as well. It's called the access operator. Weird. So what is this saying? The system class is accessing the out property, right? And the system class is also accessing the println method. So we assume here that the println belongs to the system class as well. So access just means telling these methods to execute or telling these properties to execute. So the out property is going to execute and the print ln property is going to execute. Now they're going to execute in order. So we call this, so do you notice that we have several dots here, right? Well, this is what happens is the computer's going to execute from left to right. So it's going to execute the out property first, and then it executes the print ln. Okay, so that ordered, right? The computer executes one access operator first and then the next, right? So the left to the right. So we could string multiple methods in one Java statement. How do I know that this is a Java statement? You see that at the end we have a semicolon. So this tells the computer, hey, execute this one line of code. So when this one line of code is executed, it's going to print welcome to Java to the screen. Okay, I know that was a lot, but I wanted you to get, this is the very simple Java program, but I want you to get the idea of how the computer looks at this code. This is the only line of code that is executed, okay, in all of these statements. All right, so from there, you've heard me say this word compile and running or executing. Well, let's walk through how the computer reads the code and how things are. When we just trace through that code, it was done quite quickly, right? But there's some things that take place behind the scenes, and I want you to be mindful of that, because I know in a minute we're going to be using these programming environments, and a lot of these things are kind of hidden to us because, you know, these sophisticated programming environments. But here's what happens. Here's the process of writing a program. So source code, let's get used to using some terms here. I want you to, our vocabulary. So the programmer writes what we call source code, which is the program that we want the computer to execute. So source code, we call that source code. So we're going to be writing that public class welcome and in public static void main. We're going to be writing that code in our programming environment, right? After we've written our algorithm, we're going to translate that algorithm into this code, okay, using the specific language of choice. So this is the Java code that we've written. So given the Java program that we've written, we've got to save it to a computer, right? Save it to memory. And then once we do that, so there's our source code right here. Once we save it to the disk, save it to memory, we're going to then we want to compile it. Right? Now, this is our welcome.java file. We want to take our source code, right? We created it, saved it in memory. We want to then compile it. Well, compiling it, we don't necessarily have to do this when you're using sophisticated programming environments. You don't have to, but this is the actual code in order to compile. Now, what is a compiler? We talked about it last class period. Compiler is like a translator. It takes that source code that's written in a high level language like Java, English like statements like Java, that the computer does not know how to read. It takes that high level language, and our compiler's role and responsibility. Here's the role and responsibility of a Java compiler. And write this down. A Java compiler, or a compiler in general, does the following. It examines your code. And what do I mean by examine? It examines your code line by line to make sure and enforce the strict grammatical rules of that language, right? The rules of the language. It checks your code to ensure that you have not violated the grammatical rules of that language. That's what a compiler's role is. That's one of the roles of a compiler. First, is to check your code, inspect your code to make sure that you've not violated the rules of that language. The rules are built into the programming environment. So and what are some of the rules? We're going to be learning those rules throughout the semester. Did you leave off a semicolon? Did you misspell a reserved word? Are you using a reserved word in a way that it's not intended? There are a lot of, so grammatical rules are evaluated. And if you did not violate the rules of the language, then your program will compile successfully. But if you did violate any rules of the programming language, and every language has its own compiler, because every language has its own strict grammatical rules. So here, if your program compiled successfully. Now you see this word JAVAC right in front of the file name. Now we don't have to type that when we're in our programming environment, our sophisticated programming environment. We can just push a button or do something. But this is what happens behind the scenes, is that the Java compiler is called up. That's what that JAVAC means. Java compiler, JAVAC, C for compiler. So the Java compiler is going to run this program. Now, again, we don't have to type it out at the command line, JAVAC. We could do that at the command line. We could do that if we wanted to compile our program. Yes, we could. But most programming environments will allow you to just push the run button and it'll do all that. Okay. But the first step is always compiling. So it compiles. If your program produces an error report, meaning there are one or more errors that the compiler found, right? It's going to produce a report for you, and we'll demonstrate that today before you leave. So if your program contains errors, it generates an error report. What do you suppose? What should you do then? You've got to then come and modify that code. Go back to the source code, make the corrections based off of the error report, and save it to the disk again, and run the compiler again. So you literally could be stuck right here for a little while. It just depends. And this is what we call troubleshooting. This is where, if you're new to coding, you may get a little frustrated, but you'll get over it. You'll learn. And let me just say this, troubleshooting, you'll get used to some errors over and over and again. You'll see an error message and you'll say, oh, I know how to fix that because I've seen it before. So I'll even demonstrate and remind you of some things or show you some errors that are common. And those could be fixed quickly. And some errors may take a little more time, right? Depending upon how complex your particular program is. So this is where troubleshooting takes place. Find an error, go and modify your source code, compile it again. Find another error. Hey, that's what it. So you will continue in this loop until the compiler says you're good to go. So I'll also demonstrate this. So when your program compiles successfully, it produces what we call bytecode. A bytecode. Bytecode is what the computer finally understands. It does not understand high-level language like Java, but it does understand bytecode. And so that is the role of a compiler. I told you the first role of a compiler is to examine your code, right, for errors, right? Did you violate the language? And the second role of a compiler is to, once your program does not contain any grammatical errors, I didn't say any errors, but no grammatical errors. And we'll talk about the differences between errors. There are different types of errors that exist. But your compiler identifies whether your program contains grammatical errors. And if your program does not contain grammatical errors, the compiler's second role is to translate your code into bytecode, okay, so that the computer can execute it. And that's what we have right here. The bytecode, that's not for human consumption. Bytecode is not for us, it's for the computer. And so, and then once the bytecode is generated, is created, then the compiler will then hand it off and run the program. We can then run the program. And if we were doing it at the command line, this is a statement that we would write in order to run our code. So do you notice to compile our code, we said Java C and the file name, including the file extension. But to run our Java program, we just say Java and then welcome without the .java extension, because it can't be a .java file any longer, because what are we doing here? When we say Java and just the name of the class, we're actually running the bytecode, and I'll show you what that means. But again, the sophisticated environments that we're going to be writing our code in, all of this these steps that you see here are done with the push of a button. And first there's a compile, and then there's an execute potentially if you don't have any errors, but you won't see these Java run commands, right? But this is what takes place when we push run. It compiles it first, and then it tries to execute your code. So once the computer executes your Java code, right, it then produces that output that we see on the screen. So you can see over to the right-hand side is just a graphical representation of the process. Any questions over this? Any questions over what I've gone over so far? So the idea of creating, compiling, and actually running. Running is the same thing as executing, okay? Executing our program. Any questions over this so far? Let me take a temperature gauge here. Thumbs up if y'all good, if all is well. All right, excellent, awesome sauce. Let's keep it rolling. So compiling, as I mentioned, that source code, the ultimate goal is to definitely generate the machine code for the computer so that the computer can execute it. Let's take a look at now the anatomy of a Java program. I kind of briefly given you the anatomy of a Java program, but let's dig a little deeper. And these are some things that you should see in most Java programs. Okay, in most Java programs, you're going to have the following, and then we're going to again shift and write some code. All right, so most Java programs contain a class name, a main method, statements, statement terminators, reserved words, comments, and blocks. So most Java programs contain this. Let's take a look at each. So every Java class, every Java program should define a class, right? Classes are what are executed by a Java program, by a Java compiler. And so here, again, you're not going to understand every line of code in this. That's not the point of this, okay? Eventually you'll be writing this like it's nothing. All right, but so what do we see here? We see that given this code that we have, this Java program on the right-hand side, we see that the class name is first program. You can see it starts with a capital letter. It follows the keyword class. This is always the case. Now, what always follows the class name? This open and closed curly brace, and we'll talk about that a little bit later. That's what we call a block of code, okay? But this is what every Java class must have, is a class, and that class name is user defined. Every Java program will also contain that main method. Remember, I told you that's like that relay race. Main method has the baton first. It's the most important method that is executed in a Java program. This is where all Java programs begin, in the main method. Execution starts in the main method. And these keywords that you see there, they will stay the same every time. Public, static, void, main, public, static, void, main. And capital S for string, capital S, because string is actually a Java class. Remember, I told you Java classes start with the capital letter. This is an indication that, hey, we're going to be learning about the string class during the semester. So string, and then that's R, and that's open and close brackets, and that's args, ARGS for arguments. But so this is what it looks like. It never changes, never changes. This is what it's going to look like. Then there's that open and close curly brace. And then there's that / end of main. This is something I like to do with all of my closing curly braces. Is I like to tell myself or remind myself and others that look at my code that this is the closing curly brace for this open curly brace, because that's going to be so important. And we'll talk about why in just a second. Okay. So all of this belongs to, all of the stuff you see right here inside the open and closing curly brace belongs to the main method. The main method. It is a method because you see open and close parentheses after the keyword main, after the word main rather. All right, so that's that main method. Every Java program is going to have a main method in it. All right, what else is a Java program going to contain? You probably can't see because it's kind of small there, but every Java program is going to contain statements. Java statements. And these Java statements are what your Java compilers are going to, or your Java programs are going to be executed by the computer. So those Java statements always end in a semicolon. Those are what are executed by your computer. So all Java statements end in semicolon, and they are executed by your Java, by the computer. And so you can see several there that are in red. They are the kind of small there, but you see that they are considered, these are considered statements because they all end in a semicolon. Another thing that you will encounter when writing a Java program are what we call reserved words, as I mentioned when I went over the definition of a programming language. Reserved words. What are reserved words? They are words that mean something special to that language. Every language has a list of reserved words. So we'll look at the reserved words as it relates to Java next week, for sure. And so here you can see a few of them up front: public, class, public, static, void, main. All of these are reserved words. And some of these, I should say, aren't necessarily reserved words, but are classes. But yeah, they mean something special, like static. I really should highlight those to a certain extent. But import, right? Void, static, main. These are all considered to be reserved words. Then the next thing I'll highlight is what we call comments, which I mentioned to you all earlier, right? Where those slash, those most Java programs, should. Do they have to? No, but they really should contain comments. Every program should contain comments. And there are two types of comments that exist. And just to recall, remember I told you that comments are ignored by your Java compiler, and they are not executed at all. And white spaces, as you'll read about in lesson 2, are also ignored. Indentions are ignored. Only thing that gets executed by Java, by your computer, are statements that end in a semicolon. So these comments are ignored. They're just for human consumption. They describe what's following, or what they describe some part of your code. They give descriptions. They tell you what's going on. They are definitely used to help the programmer communicate what's going on in the program. And so documentation is extremely important. When we write code together, every single class period, I try to demonstrate what you should be doing on your own when you're working on your own. And I definitely use comments. Documentation is extremely important. It's important that you learn that early. So while we're learning the language, let's learn the importance of documentation. It's not just for us, but for others that may look at our code, because again, software and software development is usually not done in isolation. It's done with others in groups. And so others may come behind you. So understanding the importance of good documentation is going to be imperative. All right. And it is subjective, I will tell you that. So good commenting is very subjective. It's just you writing what you think is important about what is important, okay? And so it's very subjective. Then there's also, and we'll talk about the different types of comments. They mentioned that in your textbook as well. There's, can someone tell me there are different two types of comments before I move any further. There are two types of comments that exist. What are they, do you think? There's something called block comments and single line comments. Absolutely. So one line comments and multi-line comments. And so you'll read about that for sure. Yeah, absolutely. So multi-line comments or single line comments. And what you saw there in our slides there, these are examples of single line. This is the symbol to tell the computer to ignore one line. But there is a symbol, and I believe Jennifer put it in the chat. Thank you, Jennifer. And I'll put this here. And you will read about it. Definitely. So that's the complete notation for multi-lines. So you would start it off with the / asterisk, and then write multiple lines. You can write a paragraph, you write a page, and you would end with an asterisk /. That's the indication that you want the computer to ignore all of the lines between those two symbols, okay? Those symbols. You will read about that in your lesson for sure. All right, so let's move on. The last one is that you will encounter, or what we call blocks. You'll hear me say that, blocks of code. Well, how does your computer know what a block of code is? Well, a block of code represents one or more lines of code that are grouped together to perform some task. One or more lines of code that are grouped together to perform some type of task. And so what is the indication that we have a block of code? The curly braces. So you see here this is a nested block of code. You see that for the main method, there's an open curly brace, and here's the closing curly brace. And you see everything in between there, it represents those one or more lines of code that are grouped together. So these one or more lines of code that you see right here belong to the main method. Please also notice that they're indented. They're all lined up and indented. Is that required? No, but it's doggone, I mean, it's not required, but it really should be. Right? And so why do we see indentions here? For humans' eyes, and it helps humans troubleshoot. If I can see what code belongs to who, and indentions help me do that, because I can easily just look at it and see that, right? Your code should never, ever be flush to the left margin. At least don't ask me to help you troubleshoot. If your code is all flush to the left margin, that is just a nightmare. And if your code does not include good white space, use white spaces. Do you notice here? I have white spaces in logical. I have my code in logical units, and I separate them using white spaces. You can put white spaces with every other line. It matters not, but white spaces are your friend. They're free. Why not use them? They help your eyes, okay? You want to preserve your eyes, and they help you also troubleshoot. So what you see right here is a good example of, what's missing. Comments are missing for sure here for this particular example, but the spacing, the indentions are very helpful. You can easily see what block of code, right? The block of code that's associated with the main method. Blocks of code are the symbols to indicate a block of code are your open and closed curly braces. And we use blocks of code for not only methods, but also for certain structures like loops and branching statements and things of that nature. So one or more lines of code that we want to group together. All right. There's also things that you may see like this. Do you notice that my open and closed curly brace, they're different placements, and I want you to just get used to it. This is just, first of all, I want you to appreciate that programmers are artists. We are. We can write, you can write, we can be given the same problem. I write my code slightly different than you write your code, and so we still get the same output. We can still get the same output. So, but this is my masterpiece and that's your masterpiece. And again, given the same inputs, we can still generate the same outputs, but our code may look slightly different. And that's okay. As long as we've not violated the grammatical rules of the language, we're good. And so here's one of those that it's flexible. It's just up to the programmer on what you do here. So for instance, your open and closed curly brace. Some programmers put their closing brace on the next line of where the block begins, right? So for instance, if this is the class, right, and call welcome, and all of this belongs to the welcome class, then you see here's my block. My block starts here. There's the open curly brace and my closing curly brace. Some programmers like to put their open curly brace at the start of a new line. Some programmers like to put their curly brace at the beginning of where the block begins, okay? At the end of we call this end of the line. This is what we call next line. So put in the chat, especially those who are familiar with coding, which is your preference? Are you a next line type of programmer, or are you an end of the line style type of programmer? End of the line, next line, okay. And there's no right and wrongs here. No right or wrongs. I'm just going to tell you that I tend to be an end of the line. So as we're writing code together in class, you'll probably see that I'm an end of the line type of, that's my style that I prefer, but that does not have to be your approach, okay? Very good. So just FYI, there's not a right or wrong there. The next thing I want to go over really quickly is the two types of errors that exist, right? So there are two types of errors that, and you're going to read about this in your reading, in your reading assignment, is the two types of errors that exist. First is your syntax error, and the second is what we call logic error. What in the world is a syntax error? Well, syntax error, or what we call compile time error, this is when you're trying to compile your program, okay? When you're trying to compile your program, and so given your source code, you tell the compiler to examine your code, and the compiler identifies that you have violated the rules, the grammatical rules of that language, that generates an error. That's this type of error. When the compiler identifies that you have violated one of the rules, maybe you left off a semicolon, maybe, something of that nature, like you see in this example over here at the bottom that I've provided for you. Here's the traffic class. And you see inside of main, we have two print statements, right? Traffic today. It's going to print traffic today. It's going to print is very light, right? These two print statements. You'll read about the difference between print and print ln in lesson 2, in your lesson 2 reading. But do you notice here, when I hand this source code off to the compiler, here is the error report that I get back. It tells me this, traffic.java:4. So you'll notice in your programming environments, you all, that every single line of code is numbered. Okay. And so what this tells me is it gives me the line number. It says, hey, line number 4 has a problem. That's what this error message tells me. And here is what may be the problem. It says, hey, the semicolon is expected. And it even brings up line 4 from memory. It brings up from cache. It brings it and it displays it for me, to me, right? The error, the line that may have the error. And it even has that little caret there to say something around here is not right. That little caret just says, it just points to, and it might not be there exactly, but somewhere around here, there's a problem, okay? And so this is the type of error message, and we got to get used to learning how to read error messages, but on line 4, there's a problem. So you see, I left off my semicolon. So what am I going to do? Go back, fix that, right? Add the semicolon, try run it again to see if the compiler, if there's another error, or if I fix the error. So error, when we get an error message from our compiler saying that we violated one of the grammatical rule of the language, this is what we call a syntax error, right? A syntax error. Questions over this error? All right. And then the next type of error that we may encounter is what we call a logic error. So with the logic error, your program will compile successfully. Your program, meaning you've not violated any grammatical rules of the language. But what type of error is this? Well, this is the type of error that you got to dig a little deeper and you've got to see. So put it in the chat for me, please. When do you think I will identify that I have a logic error? How can we identify? How can we find logic errors? After the program runs, after it runs. So y'all are using that vague word run. What does that mean? So Kyle, I see, but it doesn't do what it's supposed to do. Dig a little deeper there. So when Jennifer says when the output doesn't match the input, absolutely. That's what I mean. Y'all were saying some of the right things. I get what you were trying to say, but here more specifically, it means the following. Given a set of inputs, do I get the expected outputs? That means we're testing. That's really the word I was looking for. When you test your program, right? Given a set of inputs, is it giving me my expected outputs? That's when you reveal potential logic errors. Testing is how we reveal these types of errors, okay? So I hope that helps there with the type of errors. We're going to switch gears. I want you to open up your programming environment. I want to do this definitely before we get out of class today. Go to your programming environment. So here is mine. I'm going to set mine up today, and I hope we get through. We may not, hopefully, we may need to alter your class participation grade there, but here. This is my programming environment. If you're using AWS, I did ask that you go ahead and set it up already. And how do you get to this screen? Let's say, for instance, you've logged into your programming environment, whatever your programming environment is. Now, I'm just demonstrating mine. And this is for those who are using this environment, this is what you will encounter. You may not see recently visited right here. Okay, so that's fine. But in order to get to Cloud9, which is the environment that I use to program, we have to go up to this search page, right up here, the search area. And I'm going to type in Cloud9. And it will bring up the service because it it is a service that's provided by Amazon Web Services. And so here's the service that I want to use to help me write, run, and debug my code. Again, this is not required that you use this environment. So just demonstrating this, and I will post a video up too about this as well. So this is that environment. So what I hope that that you do before we leave, before Tuesday, I'm going to post a video that I want you to watch before Tuesday, okay? And that video will demonstrate, because we're running out of time, that video will demonstrate how to organize your programming environment, okay? I want you to watch that video. So I'm going to leave certain parts to the video to explain. So what I'm going to do, and though you can walk through this with me today, and you will also see it in the video, but I'm going to create my environment. Here's my environment. I'm going to, now if you're taking this course and the web development course, I encourage you, because you're more than likely, you could use this environment for either course. The web development course is the LIS 2360 course. If you're taking both courses this semester at the same time, I encourage you to create separate environments for both classes, okay? Do not use the same environment. It'll get all busy and messy, okay? So I'm going to create an environment for this course. I'm just going to give it a name. And then I'm going to keep all of the settings the same. I'm not going to change anything. And I'm just going to say create. I'm not changing anything. I'm just creating the environment. Okay. So the environment has been created. And now I'm going to open it. Just click on it. Well, you can click on it and say open, or but I want to open it in Cloud9. I just want to demonstrate one thing with you today. And the time flies when you're having fun. All right. So it will take a little time to load, just a second or two to load. But this is the Cloud9 environment that I would be using just to write our code. Again, you need any environment that recognizes the Java language. The point is, we will write code together every day in class. And I need you to be, this is not a, this is a learn by doing course. So there will be times in class I may ask you to submit your code at the end of class, or sometime during class. Hey, we've just written this program together in class. Upload it to this link for a class participation grade. Okay, so that may be the case. So in this environment, once the environment loads, it's going to look like this. Okay, for the first time, I'm going to close that welcome. And here's how you close it. That welcome tab, just close it. We don't need it. And you see this README file? I'm going to right click on that README file, and I'm going to say delete. I don't need it. Don't need it. I'm just going to delete it. And I'll say, yes, I want to delete it. Okay. So this is what your environment should look like up front. When you watch the video, I do go into depth into describing each area of this environment, but I'll just briefly describe it today. On the left-hand side, this is where our files and folders will exist right here. Now remember, we're in the cloud. It's not stored. What we're writing in these files and folders that we're creating are in the cloud. They're not on your local machine. Okay, so when we're writing this environment, Cloud9 is useful for a lot of things. If you can code anywhere on any machine, anytime, anywhere, right? Because it's not on a local machine. That's good and bad. That also means that you have to have access to the internet. So again, when you're choosing environments, consider all those things. If you're there are other softwares like Eclipse where you can download to your local machines, or Visual Studio, you can download to your local machine. So you can have both a cloud-based environment that you can access at any time, as well as a local machine environment that you can access when you have that device. All right, so here's the file tree, right? It's going to exist right here on the left-hand side. This middle panel is where we will be writing our source code. The location, the console at the bottom that you see is where our output, right? Our output. This is where the command line is as well. We could compile our programs using command line statements, or we can use that run button, which will highlight once we have a program to run. All right, but this is the environment. Again, I give you, and we can move all these tabs around. Like I can move this tab up here if I wanted to, so you can customize the environment quite a bit. In your environment, I want you to create a hello world. I'm sorry. I want you to create what we call a Java template. And in your program, I mean, in your video that you're going to be watching, I do walk you through this as well. So let me show you what I mean by that. So I'm going to right click on the main parent file, right? The main folder, excuse me, parent folder, right at the very top. And I'm going to go down and I'm going to say create new file, new file. Now, here's what I want to call this file. This is going to be my template.java file. I create a template, and I want you to create a template. And the video is going to walk you through this as well. But why do I create a Java template file? Because a Java program consists of certain things always, right? A shell of a program. So what we're going to put in our template.java file is the shell of a Java program. And that shell of a Java program looks like this. And I'm going to copy and paste it also into your browser. All right. And I shouldn't say, take out this one. I should take this out. Sorry. This is our shell of a program. So ignore, so watch this. I'm going to do this. Ignore this. This is the correct file. So that's our shell of a Java program, okay? That's our template.java file. And why do I like you to create a template is because when we're in class and we're writing code together, everybody, we can quickly write a Java program. We're going to be writing, by the end of the semester, we will have at least perhaps almost 100 files in this environment, in our programming environment, because we would have written them in class together or outside activities. But this will help us start a Java program quickly by using this template. So let me go over this template really quick. So there you see public, class name. You see that I put it in all caps. Why? Because I'm going to change the class name every time we get ready to write a program. We're going to call it the class something new. So we'll overwrite that, right? Replace that. And then public static void main strings args, open and close curly brace, closing curly brace, all of that stays the same, no matter what we're writing, no matter the program, whether it's lesson 2 all the way to lesson 8. This is the shell of a Java program, right? I'm going to save that. Now, how do you know it's not saved? Let me show you this. In this environment, now you notice I said template.java, right? But remember, it needs to always, all Java files need to end in .java. But what do you know? How do I know that this file is not saved? You see that it's gray. The gray circle there tells you the file is not saved. If I say Control S or go up here to File and say Save, so Control S or Command S, either, no matter which, depending upon your operating system. If I say Control S, because I have a Windows machine, if you say if you have a Mac, or you say Command S. But you notice that gray circle turned to an X because now the file has been saved. Just FYI, okay? Thumbs up if you at least have your template created in your programming environment. All right. Anybody need help troubleshooting? All right. How did you copy and paste into so you can copy the code that I have by saying Control C. If you have a Windows machine, this is a direct message that I have. Control C or Command C, depending upon your operating system. And it will copy the code from the chat, okay, from the chat. Now, when you have your, remember, how did I create a new file? I right-clicked on the main folder, and I went down to create a new file. That created this new file. I gave it this name. And then I Control V. V as in Valentine, or you can right click on this page and say paste, right? But Control V, your favorite, your shortcuts that you just should always know, you all, it's Control V if you're in a Windows environment. It's Control V or Command V in Macs, for Macs. Control C and Control X. These are, if you don't know anything else, you all, these top 4, I would say 4, even Control A is a very useful one. But these 4 commands, I just know them by heart. My fingers just do them. I don't even have to think about it. Control Z, Control V, Control X. You have a Mac, so you would say command, the command key on your keyboard. It goes into the bottom. Okay, I'll help you troubleshoot. Okay, after class. So what I would like to end with this. Let's create one new file. Let's create a folder really quick in this environment. Again, you'll continue. How do you save? Another question is, how do you save it? You can go up to File and say Save, or you can say Command S or Command or Control S. It's all these. Again, another shortcut that I love. You can go here and just push the Save button, or you can say Control S or Command S, depending upon your environment. I hope that helps. So that turned that gray circle into an X. That was another direct message that I'm answering. So here's what I want you to do really quickly before we get out of here is I want you to right click, ignore the class participation today. I know it may have popped up on your screen. I'll move that to Monday, to Tuesday. But I want you to right click and let's go ahead and create one folder. So I want you to create a new folder. And you're to click on that main folder at the very top, the parent folder. Right click on it, and I want you to select new folder. And I want you to call this folder Lesson 1, no spaces. Lesson 1, no spaces. And then push enter. So in the video that I'm going to post, and I'm going to post it right after class, in the video that I'm going to share with you, I'm going to walk you through on how to set up your entire environment for the entire semester. So we're going to create a folder for every lesson. We have 8 lessons. And I really should say, I'm sorry, right click and rename this one, please. Rename this one. We really should say lesson 2, not 1, because again, we begin coding and programming in lesson 2, not lesson 1. Okay, so just to be clear. Then again, I have about 3 minutes left. I want you to right click on lesson 2 folder. In this folder, I want to create a new file. Let's call this file hello world.java. That's capital H, capital W, no spaces. Now, let me just say this while you're creating this hello world.java file. We never, ever create folders or files that have spaces in them in the naming conventions. We never use spaces in the name in names that we give for files or folders. Oh, that's bad. That's bad business. Never, ever do that, you all, please. Okay. So that's my file called hello world.java. Let's open that file if you would, please. And I want to copy my template. Copy that template file. Control C or Command C is a quick way to do it. Or highlight it and then say right click and say copy. And then I'm going to paste it into this hello world.java file. You can right click and say paste, or you can say Control V and paste. I'm just going to do Control V because that's what I'm used to. Okay. Now change the name of the class name to hello world. Capital A, and it is case sensitive. All right, it's case sensitive. Let me blow it up so that you all can see it. Right? It is case sensitive. So there's that file called hello world.java. There's my class that has the same name as the file name, but without the .java extension. And inside of the main method, inside of the open and close main method, I want you to indent several times inside of this main method. And I want you to type in system, capital S, .out, .println. That's L for line. Print LN. I want you to say open and close parentheses. You'll notice that the closing parentheses will automatically be created for you because that's what this programming environment, that's the beauty of this programming environment. What else is the beauty of this programming environment? Do you notice that these words public, class, and public static void, they're all colored. They changed colors for you on you. Why? Because they are reserved words. It's built into this development environment, which is awesome. Okay, which is awesome. The job now. How I know this file is not saved because it's grayed out right here. I'm going to save it. Control S, and now that gray circle turns to an X. Now inside of my println, type in the following: hello, comma world, exclamation point. So hello, comma world. You're almost done. Promise. Okay. I'll show you that in just a second. I have a message there. Okay. And then what am I going to do here, you all? I'm going to push, once this file is saved, save it. I'm going to push the run button. Go ahead and push that run button. And you should see at the very bottom there, the output. We wrote our Java program, our source code. It was compiled and it was executed. When we pushed that run button, it did it in those two steps. Compiled it first to make sure that there were no errors, and then it ran the program, executed the program. And here is the result of the program executing. It printed to the screen, to the output stream, hello world. Thumbs up if you were successful. Okay. If you weren't, I'll help you with that. Here, have a great weekend. Here's what I'm going to do. I'm going to post a video that kind of summarizes. I'm going to post the lecture note, the lecture as well, but also a video that I want you to watch that will walk you through how to organize this environment. And that video also includes creating your hello world as well in your programming environment. Okay. And template.java file. So you all have a great weekend. And there's no password, as I mentioned, Amanda, that's going to be shifted to Tuesday's class. Okay. Give you more time. All right. So you all have a great weekend, and be safe, and get started with lesson 2 if you haven't already done so. Take care. All right. Thank you. Bye-bye.